Alright, today we're going to talk about transformations from Algebra 2. Specifically today we're going to talk about translations. If you don't have graph paper in front of you, I'd make sure you get some. I have some on the website. Otherwise, if you are watching this video another time, make sure you can print some out from online somewhere. Alright, so translations. First, let's look at what's happening here. So I want to talk about first parent functions. How do you figure out what the parent function is? Because the first thing I always do is I want to know, well, what is my parent function? Remember, parent function, that's the basic function that it comes from. So for this one, if we notice, we have a squared there. That means that my parent function for this is going to be f of x equals x squared. Now, I myself, I remember what my graph looks like when I plug that in. I remember what my graph should look like for my parent function. And I also need to memorize what my actual x's and y's are that I put in for my parent function. So I'm going to put those down in my table first. And we remember my x's and my y's. And those are the x's and y's for my parent function. And now what I'm going to do is I'm going to plug in, I'm going to graph these points so we can show our parent function on this graph first. So there's what our parent function is going to look like. Well, what happens when we go and inside our parentheses, inside our squared, we add 2? Well, this is going to be a little bit different than what we should normally think about. But what it's going to end up doing is it's going to move it to the left 2 places. And here's the reason why. I basically want to make it so this part equals -2 here. And what do I have to do so this whole inside equals -2? Well, my x value is going to equal -4, right? So that -4 plus 2 equals -2. So then my -2 squared equals 4. So really what I'm going to do to all my x values is I'm going to take these and I'm going to subtract 2 from each of them to get them so they're good numbers that go in there. So what I mean here is if I plug in -4, -3, -2, -1, and 0. Let's plug those into our actual graph here. -4 plus 2, well, that's -2 squared is 4. Notice that gets us this 4 here. All right, well, -3 plus 2 is -1. Oh, look what I got. Squared is 1. -2 plus 2 is 0. Squared is 0. -1 plus 2 is 1. Squared is 1. 0 plus 2 is 2. Squared is 4. And that's what I really want. But now when we go to graph our part, we're going to use these values, our x's and our y's from here to actually graph it. So what I mean is I'm going to do -4, 1, 2, 3, 4, up 4. That's my first point here. That's my first point. My second point is going to be -3, 1. My third point is going to be -2, 0. My fourth point is going to be -1, 1. And my last fifth point is going to be 0, 4. Now I'm going to connect my points here, and I want you to notice what happened. What it did is it took my parabola and it moved it to the left 2 places. Moved it each point over 2 places to the left. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Moved each of my places over to the left 2 places. Each point over to the left 2 places. So when it's inside, it's going to move it to the left 2 places. All right, let's try another problem. So if we look at this, again, what's my parent function here? Well, we see the squared. My parent function is that squared, so the parent is f of x equals x squared. And I'm going to graph that point here quick for you so you guys don't have to wait and watch me do it. Now notice again, I use the same x's and the same y's that I memorized from my parent function. But now what I have to go look at is, do I need to change my x at all to make it a good squared? Well, no. What's actually going to be changed are my y values. And those are going to be added 2 to each of those. So really, if I plugged in -2 up here, I get -2 squared. Well, here, first I'm going to add 2 to each of my y values, and then I'll talk about why this is what it is. All right, so now I'm going to go to each point here again, and I'm going to plug in my, and again, remember, we're going to use our last 2 here, the outside pieces here. So I'm going to plug in -2. So -2 squared is 4 plus 2 is, look at that, it got a 6 as our actual y value. If I plug in -1 for x, I'm going to get -1 squared is 1. Plus 2 is 3. 0 squared is 0. Plus 2 is 2. 1 squared is 1. Plus 2 is 3. 2 squared is 4. Plus 2 is 6. All right, so let's graph these points and see what happens here. So I'm going to graph it quick. All right, I want you guys to see what happened there. Notice what happened. It moved up 2 places. So I want you to look at the difference between this problem and this problem. What is the big difference? Well, the big difference is where that plus 2 is. Notice that on this one, the plus 2 is inside the parentheses. This one, the plus 2 is outside of that squared. It's outside of that squared piece. So when it's outside, it's going to affect the y's. When it's inside, it's going to affect the x's. All right, so I want to look at this little chart here. So it might be confusing right now, I get that, but I want to fill in the pieces here. So if I have f of x plus h plus k compared to f of x, when my h piece here is greater than 0, when it's greater than 0, that means it's going to move it to the left. Left. When it's h is less than 0, that means I'm going to move it to the right. So you have to think about this as opposite. So when it's a positive number, it's going to move to the left. When it's a negative number, it's going to move to the right. When my k value here, when my k, that's the outside piece, is greater than 0, that means we're going to move it up. And when my k is less than 0, we're going to move it down. Now really what we're going to be doing is we're going to be moving it up, left, right, the absolute value of that function. So the absolute value of h, we're going to move left, absolute value of h, we're going to move right, the absolute value of h, we're going to move up the absolute value of h, and we're going to move down the absolute value of h. What that means is if I get a function like this problem up here that we did, notice it's on the inside. So let's look at this as f of x equals the f of x plus 2 with no k. So just like that, that's what it's actually going to be looking like, because our function is x squared. So really, we're moving to the left 2. We know we're moving left 2. For this problem, we have f of x equals f of x plus 2. So it's on the outside of that f of x. That means we're going to move up 2. We're doing the same way. Confusing, I get that. Let's look at some problems so I can show you what I mean. So if we look at this one is, well, first, what's our parent function? Parent is f of x equals x squared. So there's our parent function is f of x equals x squared. All right, so now if I look at this, I know f of x equals, since x squared is our function, we're going to do f of x minus 1 minus 3. So right now, I know a couple things. Because this is on the inside, I have to think opposite. It's minus 1, so I know it's going to move to the right 1. And since it's minus 3 on the outside, I know it's going to move down 3. Well, now why do we need to know all of this stuff? In order to graph it and make a better picture here, we need to make sure we know all the pieces that are happening. So, first things first. So I know this is a little confusing. So first thing before I go and I graph these things is I'm going to go look at other examples and show you why or how I know these things. So again, let's look at this problem. We have the absolute value here, so we know that our parent function is f of x equals the absolute value of x. That's our parent function. Now we have to look at a couple of things. We have two things that are changing these. We have the negative 3 and we have the negative 6. We have to look at where they are. The negative 3 is on the inside of the absolute value there. It's on the inside of the function. So that means that we know it's going to be moving it opposite, left or right. When it's minus 3, that means that it's going to move it right 3 places. Now let's look at this minus 6. That minus 6 is on the outside of the parentheses, outside of the function. So that means that we're going to be moving it down 6. All right, let's look at another example. What's our parent function here? Well, our parent function, again, is easy to see. We just have to look at that cube piece. Our parent function is f of x equals x cubed. So now let's look at the pieces again. What are the two parts? We have this part here, and we have this part here. So our first part, that's on the inside, and opposite. We have to think opposite here. That means this is moving it left 2. Outside, that means it's moving it up or down, remember. Up or down, and this is going to move it down 1. So inside of the parentheses is moving it left or right. Outside is moving it up or down. Inside you have to think opposite. Outside you just go the direction it asks you to go. Now again, for this problem, don't let the step function make you get confused here. Again, we're just looking at our, first thing, what's our parent function? Our parent is f of x equals the step ladder, or the step function, sorry. So we have f of x equals the step function of x. So now we have two pieces again. We have two pieces. So first piece, what happens here? It's on the inside, so it's moving left or right. Since it's minus, we have to think opposite. It's moving right one place. And since this piece right here is on the outside, we're going to be moving up or down. And since it's negative, we're moving down 4. All right, now that you can tell what's happening to them, let's go and let's graph each of these pieces, each of these different ones. So remember back in the last parent function video, I said you need to memorize the x's that go into your parent function. And this is the reason why. I'm going to show you this in here. So parent function was x squared. What are my x's and y's? Those are my -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. Now, like the previous problem that we did, we need to look at what's changing. When it's on the inside of our parentheses, that's going to change our x values. And all we have to do, if we're going right 1, that means we're going to add 1 to each of our x values. So we're thinking opposite here again. Opposite. Since we're going -1, we're going to add 1. So really we get -1, 0, 1, 2, 3. For our y values, we need to look at what's changing in it. Since our y values, we're looking outside of the parentheses. So really right here, we're going to think the same direction. We're going to subtract 3 from each of our y values. So what does that mean? We're going to get -1, or sorry, not -1, +1. We're going to get +1, -2, -3, -2, -3. Now, just like the other problems that we were just looking at, we're going to look at the outside pieces here. So really, once you change those inside ones, you can get rid of those if you'd like. So if you want to forget about those middle numbers, go ahead and forget about them, because now all we have to do is graph this piece here. Now here's what my parabola looks like after I graph it. Now really, I'm going to put up the parent graph here with it, along with it, so one second. Now here's a sketch of what our parent graph would look like. So now I want you to watch what I did here. If I go to the right one place, so I take my parabola and I move it to the right one place. Just move it to the right one. And I move it down 3. 1, 2, 3. We end up in the same exact spot. And that's what I want. So if you actually plug these points in and you plug them all in, you're going to get those points. But this is a trick to be able to figure it out without having to use your calculator. All right, so let's do another one. So the absolute value of x minus 3 minus 6. Well, let's think about our absolute value numbers that we plug in all the time. So remembering those are our numbers that we actually plug in every single time. Let's think about how we're going to change them. Since we're moving to the right 3, that's going to change our x's, because our x's move left or right. So we're going to add 3 to each of my x values. So we're going to get 1, 2, 3, 4, 5. Our y values, they're going to move up or down, and since we're moving down 6, we're going to subtract 6. So -4, -5, -6, -5, -4. Now I'm going to graph each of those pieces there, remembering that we're using our outside x and our outside y. Now this is what my new absolute value looks like. Now if I go and graph my parent function again, notice that if I take my parent function here in purple and I move it to the right 1, 2, 3, and I move it down 6, 1, 2, 3, 4, 5, 6, I end up on the same piece. Given my drawing's not perfect, but you can notice that they are on the same piece and they look pretty darn close to being the same. So what I want you guys to do on your graph paper is I want you to graph this one. I want you to try and see what this one looks like. I'm going to put up the parent function, the table, everything up here, so make sure you check your answers. Now, I did draw the parent graph in this one, but you guys don't have to do that, so let me take out the parent graph so you guys can see what it looks like without that parent graph. I just wanted to show you that it moves left 1 down, or sorry, left 2 down 1. So here's what my actual function is going to look like. My x values that I'm using, my x values are here, my y values are here. Your far left and your far right numbers. Outsides, use your outside parts. All right, I want you guys to try one more on your own. In fact, you know what? I'm just going to do this one for you because the step function gets difficult. So we're moving right 1, down 2, or down 4. So remember with the step function, we're starting out right here is our first piece. Now if we're moving down or right 1 and down 4, I'm just going to take that piece, move it right 1, down 1, 2, 3, 4, and that's where my step function is going to begin. And all I have to do to continue this step function is just keep going up 1, up 1, up 1, continue doing this is my step function. And then we have to go down. Open over. Remembering that for this, our right side is going to stay open, our left side is going to close. That's all I have for right now. All we're working on first is translation. So translating, moving left, right, up or down. That's all we're working on. Next, we're going to do the dilation, which means we're going to stretch and shrink the stuff.